this is the paper session number 4. We have 5 very interesting presentations. I mean, my name is Aloysio from Natural Solution. We will start with INPERSO, with 2 presentations from INPERSO from the Universitat Politècnica de València. Professor Alapont will present the INPERSO project. Then Juan Gabriel, Secondo, Maglia will present the 3D printing system for Façade restoration. And then we go to the Centro Tecnológico de la Construcción de la Región de Murcia. I think that Carlos will present, but Miriam is also here in case there is any question. So it's about the SNUG project and the advancing sustainable and energy efficient buildings through circular material innovation at optimal cost. So it's a little bit too long. Yeah. Then Giulia de Aloysio from CERTIMAC will present the circular building passport to support sustainable and positive energy homes, which is part of the LEGOFIT project. And then the session will be closed with Constantina-Dia Andreouli from MIRTEC, also INPERSO project, presenting mapping sustainability construction materials supply chains. And at the end, I will close the session. The presentation will be more or less 10 minutes, 12 minutes. We will do the questions after the presentation. If you have any question, anybody wants to ask something, please do it after the presentation. So we start with the presentation. We control the time and thank you to give you in the 10-12 minutes. Okay.
Thank you, Ruben. Thank you for your understanding of our needs and for make so easy everything to us. And I'm sorry for the inconvenience for the organization. Okay, presentation. Well, thank you for attending this presentation. I'm going to present the general aspects of INPERSO, industrialized and personalized sustainable societies. Well, I think everybody knows this challenge, this big challenge to the construction sector. I think we have told it this morning in the first section. 40% of final energy consumption and 36 of greenhouse gas emissions. We are guilty for these numbers, and well, we have to focus on renovating existing structures to mitigate this problem. However, the renovation rates have stagnated. What is the proposal of INPERSO? INPERSO proposes innovative solutions, flexible to adapt to the specific characteristics and needs of each building and user, and industrialized and digitalized processes to improve the retrofit works, reducing the time and disturbance and increasing comfort and energy savings for everyone. Well, let's have a look, a quick look on the project in a nutshell. INPERSO tries to look into the problem from a threefold perspective: products, processes, and a human-centric approach. This means that we try to be holistic and cover the whole life cycle. That's because the project will feature 3 distinct phases: the decision and design phase, the first phase, pre-retrofit, that includes collecting all the data and the information, identifying system requirements, specifications, and developing low-carbon renovation models. Okay, we were talking about the second phase, during retrofit phase. We are going to install advanced renovation components and technologies. Well, we will see something more about it later. The third phase is the validation phase, validation and demonstration phase, the post-retrofit phase. Using wireless sensor network, the project will provide holistic energy management using AI and machine learning, allowing to users to optimize energy usage. Well, this is our consortium. It's a large consortium. We are 22 partners coming from 9 countries. Many people from Spain, but also from Greece. We are 8 RTOs, also 8 SMEs, many SMEs, and 3 large enterprises, and also 3 NPOs that are in charge of this of our 3 pilots. Well, let me. Okay. Now we move to the objectives of the project. We have 6 integrated results to achieve in INPERSO that are aligned with the project's objectives. The first is deliver integrated digital platform. The second one is to generate new carbon renovation models. Sorry. The third one is try to improve the using of advanced manufacturing technologies. And specifically, we are going to deploy on-site 3D facade printing that Juan is going to explain in the next presentation. We try to also address personalized energy and comfort requirements of users. And finally, we want to deliver a complete system test in the 3 pilots that we are developing. And we are going to do this using advanced technologies. Starting with the RE Suite platform, and that is an AI and AR-based solution. The platform has been already developed in the project. We are in the 3rd year of the project, and it's been tested in the 3 demo cases in different scenarios. All the information and data are available through a user-friendly interface, and we are including the Sky tool that can recognize objects from a points cloud and integrate it into a BIM model. It is also connected to the Rialto application, which uses artificial intelligence technology to audit and report on construction management work. And R2M is developing a big part of this. Moving to the low carbon renovation models, INPERSO aims to address the fragmented construction value chain. Low carbon renovation models developed are prioritizing user satisfaction and sustainability, working together with all the stakeholders. We have developed also a dynamic map that has been integrated to the RE Suite platform, which will help all participants to make better decisions. The energy and comfort optimization interface is the last one of the digital tools. We have, well, it consists of a multi-stage energy consultant system that is connected to this interface, using a low-cost wireless sensor, wireless network sensor to evaluate air quality, energy demand, and comfort conditions. And finally, the retrofit kit, the physical part of our project. It aims to reduce construction and demolition waste, enhance productivity, upskill the workforce, improve workplace conditions, and reduce embodied CO2 of buildings. This is the retrofit kit. we can start with the smart wall. It's a prefabricated all-in-one wall panel. It's a multi-layer system that can even include autonomous air conditioning devices and other types of products as PV panels and so on. The second is the energy pod. It's an intelligent plug-and-play HVAC system that uses PCM material, and it incorporates also energy storage and PV inverter. The third one is this type of building integration photovoltaic panels to be installed in roofs and balconies with a special interest in heritage buildings. Next, we have solar window. The solar window includes a PV Venetian blind shading device inside an insulating window between two glasses. And well, this kit is composed by some of our innovative products that INPERSO is going to integrate in the pilots in order to achieve TRL 8. Of course, we have the 3D printer system, but I'm not going to talk to you about it because the next presentation it will do. Okay, let's move to the pilots, to our 3 pilots. We are going to explain briefly these technologies that have been implemented in the demo cases. One is located in Spain, the second in the Netherlands, and the third in Greece. The first is a social housing rental building whose main facade and volume are protected and with market on its ground floor. Well, Calle Estrella is located in the historic center of the city, and you can see in the pictures the 2 facades that has the building, one facing to the city and the other to the courtyard. And well, we have had multiple difficulties to develop this project, but finally we are developing the project. Of course, we are monitoring 10 of the 16 apartments, and we are doing interventions in 7 of it. The first one is installing 6 new balconies with 5 PV panels, groups of PV panels that are going to be installed in the back facade that is not protected, and will receive this facade commercial ethics. You can see the final design on the bottom right side of the screen. We are going to install we are going to install in 4 apartments this type of solar windows that are designed specifically for the protected facade, the main facade. We are also installing 4 units of the smart wall on the indoor side of the facade. And finally, 4 units of the energy pod will be fitted in 4 apartments. Moving to the next pilot, the Trinity Complex, it's in Bell. There are 3 high heritage protected buildings, the church that was not allowed to intervene, and 2 ancient monasteries, one called Emmaus and the other Bronkhorst, that have been converted into temporary residences for low resource people. Due to this high level of protection, the intervention has been finally restricted only to Bronkhorst Monastery, which has been monitored since the beginning of the project. Well, despite of the small scale of the intervention, a big impact is expected due to the big issues that always appear on this type of heritage building. Well, the work is small, but the results are huge. Only 1 room is going to be intervened, installing a solar window and a smart wall unit. But also we are going to install on the area 1 energy pod on the attic to supply 2 of the rooms. And finally, we are going to do the most interesting intervention for me, the most interesting restoration work that it consists in replacing part of the damaged chapel roof with photovoltaic tiles. with the same shape and the same finish as the originals. Well, this is the third pilot. It's located in Baribola, Poliameni, near Athens. I don't know if I have said correctly. It has yet completed already completed its renovation, and unlike the previous two, we are starting it in the coming months. And it consists of the energy renovation of a social residential building that is built in the 1960s, now dedicated to people at risk of exclusion. In this case, in order to compare INPERSO technologies with traditional solutions, a commercial ethics has been applied to some parts of the facade. On the right side, you can see in two levels, in blue, and on the left side, you can see in the side facade and the main facade, the southeast facade. At the same time, the smart wall solution was installed in the first level of the south facade, as you can see in pink, employing 27 units, 4 of them with ventilation system integrated. INPERSO panels from Metso were also installed at the pergola, as you can see in green, and the roof. Conventional panels, not integrated panels. And finally, this is the last, sorry, Ruben, for the extension. We present the expected impacts that are already being evaluated. You can see both time and cost savings and quality improvements regarding the full life cycle, the construction phase, and the operational phase. And thank you for your attention. That's all.
If anybody has a question while I put the next presentation, feel free to ask.
Yes.
You know,
do it now because we are going to
yeah.
to leave.
No, I have a, do you have anybody have a question about the project? If not, I ask. Okay,
Come on.
I saw that you had a few sessions with the stakeholders.
Yes.
How different were between different countries? You did, I suppose, one in Spain, one in Netherlands, one in Greece.
Yeah. Well, I'm not directly participating on the sessions, but I know something about it, of course. I think in Greece it was very, very difficult because tenants or residents are people at risk of exclusion, and they are not very interested in this type of renovation and so on. And they are changing, I don't know, every period. I think that here the most important is the managers of the building, the contact with the managers of the building. They are willing to participate and to do this type of renovation. That was good with them, but with many restrictions about the residents. In Spain, it has been difficult, but I think it has worked better because the tenants, because they are tenants and they are not owners, it's managed by a public company, AUMSA, and they are in contact with the tenants every time and trying to engage them, and well, with the help of our partner that is represented by Raúl. He's from Tau, and they are doing a very, very good job with people. And well, I think that's because in Valencia we have been able to intervene with many in many apartments and with the engagement of the people. And in Belp, well, it's more or less the same with the residents as in Greece, but it's more difficult because the managers of the building have been changed and they are not very involved in the project. That's because the size of the scope of the place.
Okay, thank you.
Thank you.
Please,
Thank you, Ruben.
Gabriel, please, if you can present your.
Well, I also want to thank you, Ruben, for allowing us to be first. We have a problem with the flight, so that's why. So, well, I'm Juan Secondo, and I'm representing the technical management team in the Universitat Politècnica de València, led by José Luis. And I'm going to present the 3D printing system for facade restoration that is co-developed with VIAS, ITA, that we also have Carlos here, CARTIF, and us, Universitat Politècnica de València. So I titled it Overcoming Low Productivity and Integrating BIM Technologies. So I will briefly go through the context and previous experiences regarding 3D printing. The INPERSO project I will be very brief because José Luis has introduced very good the project. And then the perform test until now, the positioning system and extrusion tests, and the conclusions with the main remarks and future work plans. So the current situation is that we have a construction sector that is facing huge challenges regarding the adoption of new processes and technologies. Industry 4.0 is crucial to help accelerate processes and gain more quality increase and safety. And we can see that prefabrication has already gained a lot of momentum, but we are still lacking the provision of flexibility and adaptability in the on-site work. So that's why we are, let's say, it's the context of this technology. So we need to aim that construction can merge industrial precision and speed with the adaptability of the traditional methods as well. So as UPV, we had some previous experiences in horizontal printing, always generating the codes for the trajectories and exploring with the different kinds of pumps. And we have also as the context that VIAS and CARTIF worked in a project called CTCON that had some of the preliminary experiences in printing vertically. So, as you know, José Luis already explained the project very well. We have 3 demonstration sites, but we are focusing now on one of the technologies that is aiming also to level up the TRL, that is the 3D printing. So in the scope of INPERSO, we have that we are developing the extraction, this is our task, the extraction of the BIM software of the layer that we want to print. And with this, we have a main orchestrator that uses the 1 to 2 G codes that we are programming, one for the global positioner that positions the pump in different sections. And then we have the robotic printer arm and mortar pump that are going to print in an area of 1.5 diameter circle. So when we focus on the global positioner, it's being developed by ITA, and we have an XYZ axes that are being, let's say, developed with a motorized trolley with a rack and pinion mechanism for precise facade positioning. And this system has achieved a very precise and stable structure that was also developed considering the stability of the system. Then regarding CARTIF and ITA and VIA, sorry, we have, I don't know if it's transition. Yes. We have a UR20 robot that is the one in charge of the positioning of the pump and the printing. And this has been developed ensuring a flowmatic extruder with dual cameras that also help monitoring the 3D printed areas. Also with a LiDAR system that detects the elements that may be collisioning with the system or that may not be present at the BIM model or at any of the scanning elements. Also, it's important to say that R2M has provided the scanning of the building, so we have the pre-existing conditions of the work. In our task as a UPV, we are, as I was saying, developing the transfer from the BIM work till the GR codes. So as you can see here, we have the wall partition in the BIM with the openings, and then we define the areas that are the maximum areas that can be printed by the robot. So we position these areas considering the holes, and then we define the trajectory from point A to B, knowing that we want to aim the shortest time and the best adherence and the best conditions for the surface quality. So we aim at the less assistance from an operator as possible. Finally, when we talk about the printing process, there were many tests. So we had to test the adherence, as I was saying, how this much distance of the layers, the flags of the products so we can aim to the most optimal surface, so then the operator has to do as less possible work, the less possible work. So the aim is to perform with little human assistance, as I was saying. It's important to say that this robot is a collaborative robot, so we are aiming to also for the safety of the operators. Here we can see how at the beginning we were testing in a 6x6 surface, how these 1.5 per 1.5 squares were going to 1.5 circumscribed square within the circle was going to be positioned, and then testing the different kinds of distance between the layers and the extrusion of the pump as well. Here we can see the LIDAR element that is also detecting any variation in the surface for this to be done in the perfect way. So as main conclusions, we can see that this technology aims for existing buildings, which is one of the biggest challenges in construction, and also we are trying to aim for energy renovation, so to give this mortar the thermal properties in the future, so we can actually use it as an insulated element. As you know, outdoor insulation is the best solution for avoiding thermal breaches, so this is a good road of work that we are in. So also the collision identification, not just for the openings, but also for the overhangs and elements that may be present, is a very huge problem of the retrofitting industry. And also the BIM workflow will allow for much better and fluent relation between the project and what is actually performed. Also, when we include these scanning elements with LIDAR, we can have very precise approach of existing conditions, which is not always as projected, as you know. So, thank you very much. If you have any questions, please.
Very interesting and quite impressive. I like it. How does the thing stick to the wall? Is it sticking or is it falling sometimes? Or?
Yes, for that, that is being developed by BIAS, the material composition. It was very important to ensure the right amount of viscosity to stick, but at the same time, the right amount of fluidity to circulate smoothly in the pump. So this was performed with a lot of tests in order to achieve the best.
And I was wondering, when you top, in many cases when you renovate, they use this mesh, this very fine mesh, right? And manually they put the mesh, and they slap the screed on top. You're looking to do that as well, to see how, when you introduce this extra layer component, is that necessary, or I don't know?
Yes, I understand that in the future, because we are still on a very controlled area, but it should require some mesh, because when you are working with very long surfaces, that's why it's so important that it's a collaborative machine. That is not, that you leave it working and you go away, but you really need the operator to be doing this kind of continuity of the material.
All right, well done.
Thank you.
I have another question. Is this going to be also TRL8? What is the status of the...
No. Yes, it's TRL6 at the time, and when we tested that it will be done, well, as José was saying, we are in the last year of the project, so once we test it on a real site, it will be TRL7.
Okay.
Yes.
And what are the next steps? So the things that you have mentioned about the circularity and so on?
Yes, the next phase will be we are researching on materials that have thermal properties, so the idea is to aim for that, to aim for really best performing materials, because they will ensure that also the technology provides an extra benefit.
Thank you.
Thank you very much.
Well, safely back to home, to the UPV team that they have to leave for the airport. And now we go with the next one, with the presentation, which is Carlos Rodriguez from CTCON, and he will present the SNUG project.
Okay, I'm going to present the SNUG project. My colleague Marina from the University of Honduras presented the project yesterday. We presented the project yesterday in one of the workshops. So in this paper session, we want to show you some of the material solutions, advanced material solutions that we are developing in the project. The project is composed of 17 partners from different European countries. IDIME is the administrative coordinator, and CTCON is the technical coordinator of the project. As I said, Marina gave yesterday an overview of the project, so I'm going very quickly on this, and then I will present some of the solutions that we are developing. The mission of the project is clear: try to maximize building energy efficiency and minimize greenhouse gas emission. The main goal of the project is develop and demonstrate a new methodology to help builder, architect, engineer in the selection of the most appropriate set of thermal insulation material or construction solution, taking into account the whole life cycle of the building. I mean, the production of the material, the construction, the use, and the end of life. To achieve this, we are developing in the project a digital tool assistant based on artificial intelligence. We are developing a different thermal insulation material and a database of thermal insulation material with information about the LCA and different performance metrics. Regarding the specific objective, the first one is to develop all this solution, this advanced solution. In particular, in the project, we are developing different low carbon solution based on low carbon cement. For example, we are developing AAC block, self-leveling mortar, rendering mortar. We are also developing self-leveling mortar with phase-safe material to improve the efficiency of the system, different types of aerogels, and finally a new facade panel, bio-based facade panel. The goal of this solution is to reduce the environmental impact, improve the energy efficiency, and try to remain the cost, or even producing with a lower cost. And the specific objective 3 is to develop this digital system, able to select the best thermal insulation solution and taking into account this aspect of LCA, cost, efficiency, and so on. And finally, we are going to demonstrate this new methodology in 3 real buildings in Norway, Spain, and in Switzerland, each one with different characteristics and use. And in this part the project, we are now in month 24 of the project, so some of the solutions are very advanced. I'm going to show you some of them. In this case, the low carbon solution. In this part of the project, CTCON, BEXA, and CRH have developed different low carbon solutions. We have worked in parallel. On the one hand, we have developed low carbon cement for common application, such as rendering mortar or self-leveling mortar. And on the other hand, we have developed low carbon cement for AAC block. The reason for working in parallel is that the chemistry of the Portland cement for common application and for AAC is different. Because in the case of the AAC, we want to produce as much tobermory as possible. So this is the effect that gives AAC its strength. But in the case of the Portland cement for common application, we are not generating this phase because we are not using hydrothermal treatment. In the case of the low carbon cement for common application, we have developed both geopolymer and blended cement using different type of local waste, such as biomass ashes, recycled diatomites, and so on. And here you can see the final technical data sheet of this low carbon cement. In the case of for example, the cement, we have developed one of them without clinker and without Portland cement, and we have a reduction of 80% in CO2 emission. the property of this cement is similar to a cement type 2, 40.5. And in the table below, you can see the property of the rendering mortar. And this is a conventional mortar, the same property, but with this low carbon emission. Moving on to the next slide, here we can see the solution with AAC blocks. For those who may not be familiar with this type of product, this is a precast building material with very low density, very good thermal insulation, and high durability. And we usually use this product for the construction of facade. Here you can see the material that we usually use in the production of this product: silica sand, cement, lime, gypsum, a return slurry of the same process, the cutting process, and aluminium power as foaming agents. As the goal of the project is to reduce the cost and reduce the environmental impact, we have focused in the most expensive and high CO2 raw material. In this case, we have worked to remove or replace part of the cement and the lime. This is the process of the production of this type of AAC block. You have a first step, the foaming process, the pre-cooling for 6 hours, and then they go to the green cake, go to the cutting process, and finally to the hydrothermal treatment, and the product is ready for the market. Here we can see the best formulation that we have obtained in the project. I'm not going to present in this, only the key point of the most important point. We have removed completely the Portland cement in this type of formulation, and we have replaced part of the line. In this case, we are using blast furnace slag in order to remove the Portland cement and garbage slag. And here you can see the foaming of all the mixture is very similar between all of them if we compare with the reference one, the control AAC. And as you can see, the density is very similar between all the mixture. Regarding the mechanical properties in the mixture with this material, as I said, blast furnace slag and garbage slag, we have very similar behavior between them. And as you can see in the table below, we are generating the same, more or less the same thermorite as in the reference one. This is the key point in this type of product, in order to remain the same properties. Here you can see all the properties of this different solution. In this case, the first column is the reference product, and the other two is with this new formulation. For example, the thermal conductivity, as you can see, is very similar between all the formulation. And regarding the LCA, this is one of the key points of the project. Here in the table, you can see the percentage reduction for all the impact category. As you can see, we have reduction in all the impact category. For example, in the CO2 emission, we have a reduction of 88% if we compare with the reference mixture. And finally, very important, the cost. The idea of the project is to try to do this, but with to develop this product with a lower cost. So here you can see the price for 1 cubic meter of the conventional AAC, and with these two type of formulation that we have developed in the project. As you can see, we have this lower cost in the production, With this, we want to show how we can produce this low carbon solution without increase the cost. Because this is very important to accelerate the introduction of this type of material in the market, as everyone know. And the idea is to, with this product, is to go to the industrial scale and to start with the certification process and go to the market with this now a new product for all the solutions that we are working on. Sorry. And here, if you want, here you can find more information in the website of the project or in the different publications that are in the website too. Yeah, and that's all from my side.
I took note of a few questions, but please.
I have a question. I was wondering if you actually deepen the process through these calculation, information, and development you did towards the DBL as last, material inputs, data calculation.
The DBL?
The digital building logbook, sorry.
Yes, the idea is to include all this information in the EPP of the product, and with this information you can use this, for example, to fit the digital tool system, because the idea of this new methodology is that in the digital tool system you have different parameters, for example, LCA, energy efficient, cost, and the designer or the architect or the engineer can decide the weight of each which part. For example, the cost is more important or not. I prefer the performance of the solution. And yeah, the idea is that to have all this information in the digital tool system to have the output of this tool in order to design new building, because the idea is to use this tool in new building and in retrofitting work.
So basically, if you understood correctly, then the main output is having several different scenarios based on this digital tool, and then those scenarios will be stored in the digital building logbook, right? Yeah. Okay, thank you.
Any other question? I took note of a few, so I will ask a few. So when you presented the AEC blocks, there were two alternatives, and you presented a list of different, let's say, reductions. Overall, which is better? I mean, of the two, do you have any preference of one of the two? Because I saw that one, I mean, maybe it was reducing more the cancer or whatever, or other one was more, I mean, between the two, at least are more or less similar in general terms overall, or?
Yeah, in general terms are similar, but the cost is in the first one. In this first one, we have more or less more cost reduction, because in this case we are using only 30% of the amount of Portland cement, initial Portland cement. In this case, we are using the same amount of Portland. We replace 100% of the cement with this plus component, but the behavior is different. So from the environmental point of view and the cost point, this is the best option, because you have a better behavior in LCA and a better reduction in the cost of the product.
And the idea is try to go to the market with both, or just prioritize this one, or allow, I mean, based on the let's say the KPIs, maybe allow the client to select one or another. What is the objective?
It depends on the company, CRH, because in fact they have, we are developing this in Romania, in one of the plants that they have in El Preco, but they have other plants in Europe, and yeah, it is going to depend on the company decision. I imagine that they are going to prioritize the cost. I imagine that, I don't know.
Okay, and you mentioned also that the plan is to go to the market soon.
Yeah,
soon
at the end of the project.
In 2 years. Okay, perfect. Okay. Maybe challenging.
Yeah.
Thank you.
Thank you.
Okay. So
we go with the next presentation. Let me try to open it. So with this one, right? It's fine.
Okay.
Okay. So Giulia de Aloysio from CERTIMAC is going to present LEGOFIT. Thank you, Giulia.
Thank you, Ruben. Good morning, everybody. Today, I will share with you some details about circular building passport to support sustainable and energy positive homes, which we are going to develop, which are developing currently within the LEGOFIT EU project. So, why we are here first? Well, we are here because the building sector urgently needs tools that integrate energy, circularity, and social dimension, and the EPBD recast highlights digital logbooks, building logbooks, and roadmaps, and life cycle assessment of build and also building passport as key drivers towards decarbonization of our building stock. Today, we discovered together how LEGOFIT, our EU project LEGOFIT, is turning this vision into practice by developing our circular building passport, by aggregating data at building level, embedding environmental, social, and economic indicators, providing a decision support platform for design, renovation, and policy, as well as enabling replicable, scalable renovation pathways for energy positive homes. But let's go into deep of our context. Well, our context now is really requires a call for change, because we have from our data, from the data available from the EU Commission, we know that about 30% of the energy consumption comes from the EU building stock, and then our deep renovation rate average among member states is about 1%, and about 35% of total new waste comes from construction, demolition, and renovation of buildings. About 50% of the extracted materials are consumed by the building and construction sector, as well as 15%, about 50% of the total building emission comes from embodied carbon materials and construction sector. Why do we need a circular building passport? Well, because we have to tackle several challenges, like today the data about circularity are fragmented and inconsistent. Sometimes transparency for decision makers and citizens is lacking, and the EPBD recast pushes for LCA logbook and passport, as I told you before, and circularity, comfort, and affordability are poorly integrated all together. In this framework, the circularity passport directly addresses this gap by consolidating all the relevant data in a unique document, providing a transparent digital and EU-aligned tool, and also enables better design, renovation, and investment decisions. And why does it matter now? Because the PBD, as I told you before, puts a strong focus on the energy performance of buildings and also decarbonization of buildings up to 2050. And then the PBD now enforces the obligation to evaluate the global warming potential by using the level framework. And also the PBD pushes towards digital building logbooks and building passports, and requires that data are comparable and transparent across the EU. The circular building passport works on these aspects and provides a practical methodology in principle to assess not only energy but also circularity, uses LCA, the LCA methodology to calculate building global warming potential across the whole life cycle, and supports data collection and digitalization. Additionally, the CBP is designed also to be interoperable with other tools and is built relying on indicators also coming from trusted schemes like certification schemes like LEED, BREEAMS, DGNB, thus strengthening its acceptance into the market. So our circular building passport is developed within the LEGOFIT EU project. LEGOFIT stands for Adaptable Technological Solution based on early design action for construction and renovation of positive energy homes. This is an innovation action coordinated by Demir Energy. Here we have our coordinator, Pérez, and we are 17 partners, let's say, and apart from R2M, that is here, we have LIST, which is actively and effectively supporting us also in the development of this of the circular building passport. But let me give you only a brief overview of LEGOFIT. LEGOFIT aims to design and implement and validate an adaptable, dynamic, and holistic approach to accomplish energy positive homes. And in particular, LEGOFIT provides professional and end user with a holistic platform with three main functionalities. The first one is support the decision-making process. The second one is aid the design process and sets up an innovative marketplace. Well, the circular building passport we are currently developing, is one of the tools that LEGOFIT is making available, and it acts as core element. Since it consolidates really life cycle data on materials, energy use, circularity, and environmental impact. And the circular building passport really embeds sustainability and circularity early from the onset of the design decision of the design process, let's say, through both for renovation and new construction. And the circular building passport in this way allows for informed decision-making, better tracking of materials, alignment with EU policies, as well as scalable, replicable renovation pathways, because it will be tested and validated in different EU contexts. Well, let me ask for a question. What is the circular building passport? Well, when we started designing this tool, the first question was, what is the circular building passport? And faced a big challenge because there is no single universally accepted definition for the circular building passport. However, there is a common understanding that it is a digital document that builds and collects data from single material passport, tracks embodied carbon, circularity, and reuse potential of materials, especially, integrates energy comfort and affordability indicators, and provide a life cycle perspective for design, renovation, and policy decision makers. In this framework, in LEGOFIT, the CBP is developed as a practical methodology that connects materials, building, and decision-making, thus ensuring the sustainability and circularity are embedded really throughout the whole life cycle of the building. Our circular building passport is structured into 3 steps. First of all, we started from material passport, that provide us data of product and component level. And here, the info we have are the composition, impact, reuse, recyclability, and embodied emission of materials that are in our building. The second step consists in aggregation, that is collection of all the data coming from material passport from one building. And this second stage, we add energy, comfort, cost, and accessibility, hopefully interoperably with PIM, DBL, but especially with LCA tools. And the third step, we built really the circular building passport, that is a building level integrated document, which will add holistic indicators like global warming potential, circularity, social, and economic. In this way, we enable comparison, monitoring, and policy alignment. Well, our document, our circular building passport, basically is structured into 4 main domains. First of all, we have the environmental indicators, that is global warming potential, as I told you before, that is basically based on product environmental footprint methodology. And we have also circularity indicators like recycled content or used content and others. Here we have 2 other domains, that is social indicators and economic indicators, and you see they are a little blurred because it is like a work in progress, because we are going to tackle them. But while for the first 2 domains, let's say there are more standard methodologies already stable on the market, for the others we do not have precise, at least for the social indicators, we do not have precise indicators on which we rely on, and we want to also to let's say integrate it with other schemes, and also with other potentially with other tools we have in the LEGOFIT project, like the Voice platform, but it is really a work in progress. How do we create our building passport, our circular building passport? Well, it's what I call the 3C for our circular building passport. First of all, is to collect the data, the material and building data. The second step is to calculate indicators by using LCA tools to calculate environmental, circularity, social and economic indicators. And then the third one is the last one, interpret the data and create the final dashboard for the circular building passport. Well, the CBP basically helps us throughout the whole life cycle of the building, from, as I told you before, from the early design, that it is to compare different options of materials that we, and also of solutions that we have to include in our building, up to the end of life, reuse and recycle of the resources through the different renovation pathways, as well as operation and use. And also it is a tool that supports architects, designers, professionals, but also investor developers, but last but not least, our citizen and end user, because we are going to guarantee more comfort, more affordability, and more transparency. I think here we have this tool is like is considered as an innovative tool, and it has both potentials, of course, as I told you before, enables comparison, promotes innovation and transparency, but it has also we identified really three main challenges. That is, data difficult to find or not available. Data collection is the data collection step can be time consuming, and the third, we have difficulty in assessing social and economic impacts because they are less, let's say, explored. In summary, now we are, let's say, our circular building passport is really helping us to put the APBD into practice. Beyond LEGOFIT, the circular building passport ensures that it is a reference for energy positive homes and more scalable to energy positive district, because it provides us with holistic data integration. It aggregates data from materials up to a building scale. Of course, it's a decision support platform, and foster sustainable renovation and construction pathways, and of course, ensure policy alignment. So I think that's it. Thank you for your time and for your attention.
Anybody has any question about the presentation? You have, please.
Can I ask, is it easy to collect all this data from all the value chain?
My question.
Because it will be a brilliant tool, but can we have this tool at the end?
Of course, this is a very good question. We are piloting now our collection of data in different ecosystems. Of course, is one of the most challenging steps. And that's why we try really to start from more advanced realities, which have already, let's say, other tools from which the data can be extracted, and which are more, let's say, which is easier to, for example, collect data as APDs and so on, and trusted data, I think. Kalin, if you want to complement.
Yes, I don't know if you were maybe in the other room before. I was showing how we aggregate circularity scores and life cycle scores, but I just had two charts to explain that it's difficult to get accurate data. And we kind of had to manually look for technologies on the market and see if they have EPDs. If they have EPDs, we have to read them, interpret them. If I had digital material passports, I don't know what they call it, that would be great, but there aren't any. And we kind of have to look to the data that we need for the calculations to happen. And then there's also a question of how do you aggregate it at the building level, because these are products, and then this is a building level score.
Yeah.
And yes, it takes time. It's hard, but let's hope that in the future we have more tools to do it. Yes.
And if I may add, another aspect that we proved to be challenging is that sometimes the APD we can collect are, let's say, out of date.
Expired.
Expired.
Thank
exactly.
you, Julia.
Yes.
I also had that in mind. So
expired.
they sometimes they expire. Okay, that's fine. But the problem is that, for example, so that means you have not accurate data for old buildings. So right, for old buildings, very little chance of you getting data. So you can, if you find an EPD from 20 years ago, the actual global warming potential impact today will be different because a lot of things in the background, the supply chain and the way that carbon emanates in the environment also updates. Right, the scientists look into that. They change the characterization factors, and then there is another aspect of the methodology changes. The LCA methodology changed with different indicators, but then the European Commission has established that we want to use environmental footprint methodologies and the PEF as a single score aggregation methodology. So at least on that sort of level, that's kind of fixed for the moment. But I mean, policy makers, they really like to play with a lot of things.
So the challenge is not only having the data, it's having accurate data, having quality data.
But I guess the good thing would be that once you have the data, that you know that is relatively static, let's say, right? You know the amount of materials that you have, you know the type of material that you have. If some things along the methodology change, you can recalculate it, right? So that's what, once you have the data, the effort is not for nothing, because even if in the future you need to show a different calculation methodology, maybe, not LCA, but something else, I don't know who else will come up with something. A lot of the data is now there, so you can just look into it and you can calculate it. So that's what we had, Giulia showed you, we have social and life cycle cost things. We already have a lot of data, but we need to decide on the methodologies that make sense.
And also there, Colin, we have identified together, 35 indicators. So which one is the most suitable? Maybe we have to tailor it also with pilots. This deserves more attention, because we don't have standardized methodologies. Yeah.
Any other question? Please.
Without needing a very long answer, because that would be a possibility, and influenced by the previous workshop, the possibility of interacting, connecting, sharing data with other tools like digital building logbook and BIM, for example. I think that this kind of circularity could be an additional dimension in BIM. So have you looked a lot at this? Do you see perspectives?
Yes, of course, we see the perspective of implementing it also in a BIM environment. Already we have the data from the Luxembourg pilot from a BIM environment, the BDC, the construction platform, that is very, very effective and provides with reliable data. But let's say we can do it for advanced context. For less advanced context, we have to investigate pathways that allow us to really share effectively data, to collect data in an effective way. Because I cannot claim I will do BIM with a not so advanced context where maybe an Excel can be more effective, let's say.
Yeah. Okay, well, one question from my side.
Okay.
No, when we do like some modeling or some analysis at building level, there is somebody always coming saying, okay, can you do this at a neighborhood level, as a city level? It is possible to implement something like this in the future,
yes,
in a different scale?
Yes, of course. It is possible to let's say, think about modeling at the neighborhood scale, but let me say that it is two-level actually, because first of all, this acts as a building block. Okay, this is one building block. No? The idea is not to collect many circular building passports of the different buildings and say, okay, we have the passport of the district, but is also to embed some other indicators like the food, for example, the accessibility of the structure of the neighborhood, that make other indicators that make our circular building passport suitable for the neighborhood. And it's something that ARUP is already, the company ARUP is already developing, and also with support of UNEP and so on. For example, considering food or waste of the city and so on. Yeah.
Okay. And how is this governed long term? I mean, if you have to govern this for, I mean, it's not like something that will last for 1 year, 2 years. It's going to be...
No. It's like, I think I would think about, let's say, let me think about a business model underlying this kind of initiative, because we always think about the policy framework, the policy level that sets the framework, sets the requirements, but then we need local professionals, one-stop shops, or other institutions who input the data, who keep this kind of tool updated, because otherwise it ends here, basically. Yeah. Thank you so much.
Julia. Okay.
And we go with the last presentation of today. Open it. So,
Here you have it. So, Constantina-Dia Andreouli from MIRTEC. Please.
Good afternoon to all of you. My name is Andreouli. I'm coming from Greece, from MIRTEC, Materials Industrial Research and Technology Center. And we'll go back to INPERSO project. The first two presentations showed you the technologies we developed in this project. And now I will present you our approach in mapping sustainability in construction material supply chains. To remember a little bit the technologies that we are working for INPERSO, we are talking about 5 technologies: smart wall, a wall panel, energy pole, building integration photovoltaic system, solar windows, and Façade 3D printer. So the objective in our part of this work was to map the supply chain for all these 5 technologies, assess the qualitative sustainability performance, and provide insights in order to improve the circularity of all these technologies, because these technologies are targeting a TRL 8. That means that they are very close to market, and all these issues need to be dealt. And in order to proceed with this, first of all, we need to understand the construction value chain, and then develop a methodology in order to identify the points that we can that can be improved. Here you can see the construction value chain. We start with the raw materials, continue the manufacturing of the basic products. Then we have the construction site, all these works. Of course, the concept design, engineering, and at the end of the construction project, of the building project, we have the phase of the operations and maintenance, until the end of life and the need for demolishing or for renovation of the building. And in all these stages, we have a large number of waste, a large number of raw materials. The construction value chain is very complex, with all these very high numbers that speak for themselves. So, in our approach to establish a sustainable supply chain, we are trying to make a qualitative analysis for the environmental point of view. And we need then to see all the landscape, the EU policy, the regulatory landscape, in order to be ready and make some actions for entering the market for the technologies we are targeting. Then we start with the collection of the data of the supply chain and proceed with the environmental sustainability assessment and validation. Starting with the very first one, the policy and the regulatory landscape, which is relevant to the sustainability and supply chains. And here we can start with, with the directives, which are have to do with the reporting, let's say, directives. The first one was in force until the last year, and we have the new Corporate Sustainability Reporting Directive, which is in force from this year. Large companies are under this scope, and in this directive, we have also the information of the entire value chain. So the entire value chain of the construction and building materials are under the scope. We have also the corporate sustainability due diligence. This is mandatory from, it's published in July of last year, for all member states until July 2026. It will be also a directive. So all the member states will have these also mandatory actions. It refers to thousands of large companies. However, SMEs are also indirectly impacted from this directive because they are becoming partners or suppliers of the large companies. So all these are affected by this new directive. And for the Corporate Social Responsibility Directive, we have also the requirement for all scopes, scope 1, 2, 3 emissions. That means, again, the supply chain is needed for all these calculations. And for scope 3, it is written that when there is a high scope 3 emissions percentage, then the companies need to take immediate actions. We can see that the construction, in the construction sector, the companies that are there, the scope 3 is 90%. So for this kind of companies, it is very important to take these actions. Identify major emission hotspots through the screening of the key suppliers, implement efficient logistics, and implement circular economy principles. So we have also the last new regulations. The new European Construction Products Regulation, published this year, it will become applicable from next year, and for first time it includes the in Annex 1 the sustainable use of natural resources as the basic requirement for harmonized technical specifications. And the last one, the revised EPPDs, when, as we saw from the previous presentations, it will be also, let's say, related with the global warming potential, and for all new buildings, it will be mandatory from 2030. So we are talking for a boom of EU regulations, directives that need to be, let's say, taking care of the companies. And if a technology provider needs, let's say, to take some actions in order to enter the market, need to know all these directives and be ready to enter the market. So in our approach, we started with collecting data for a linear, let's say, supply chain. We start with the raw materials, with suppliers of the subcomponents for INPERSO technologies. Then we have the assembly of all these components, the installation, the end-of-life treatment, and the landfill. This is the linear, but we want to have it circular. So in circular, let's say, supply chain, we can see that we have also the reuse, the recycling towards a zero landfill. That means we need to take actions in order to have the minimum construction and demolition waste also in this map. So in our, let's say, activity in collecting all this data, mainly the primary data, we face difficulties because only the first level suppliers, it was possible to give some input in our research. Even in this case, there were, let's say, non-uniform collected data. So again, there were some difficulties. And in order to go back to the value chain, we need to take also secondary data and need to make a literature review for all the components from which we didn't have some information. In order then to, let's say, to focus on the sustainability evaluation, we decided to redirect our analysis toward evaluation of sustainability in the reverse supply chain. And we, for all these 5 technologies of INPERSO project, we did the assessment based on 6 evaluation criteria. We collected for all these the locality of the first level suppliers, the degree of geographical concentration within the supply chain, the alignment with design for disassembly principles, the resilience of the supply chain with regard to critical and strategic raw materials, the efficiency of reuse and the recycling processes, but also the existence of efficient collection networks. The output of our work was the development of a geographic information system visualization tool that we saw in the next slide, an Excel tool with all the information that we collected for all these technologies from primary data collection, the materials flows and key materials required by each technology, and the sustainability, the circularity sustainability performance, and also try to give insight to each technology provider for these 5 technologies in order to improve their performance. Here you can see the visual representation of material flows for all these 5 technologies using this GIS tool. When we started the collection of data, this was the case. After the technology providers understanding that there is a need even to change the supplier or even to change and redesign their products in order to include more sustainable materials, we end up with a more centralized, let's say, map of the material flow. This is these arrows have to do with the flow from first level suppliers to INPERSO technology developers, and from technology developers to the demo sites where these technologies and these assemblies were installed. So we can see that we managed to have in Europe all the technologies and all the materials in INPERSO project. The other issue, the other aspect that was very important is to understand that we need to minimize the construction and demolition waste. But in this case, we had a big problem. We needed a baseline, and it was very difficult to find the methodology for a baseline. We decided that EPDs is one, let's say, solution, one way to compare some trusted data with our case, and we started looking for EPDs. Again, we had difficulties, as you know. In the published EPDs, first of all, there are only a few EPDs. But for the published EPDs, you can see that most of the publications refer to the very first stages of the life cycle, and only a few for the end-of-life stage. So when we managed to find some published relevant EPDs, again, there were some difficulties because you have a new technology. It is an innovative technology. Then you need to make again some assumptions in order to be in a position to make some comparisons. And here we selected the case of smart wall from INPERSO technology in order to calculate the construction and demolition waste reduction and have some quantitative also result. We select this prefabricated facade because it supports a wide selection of materials. It can have several different sizes. This system allows a very easy redesign, so it was easy for us to redesign and change materials in order to see the effect on the construction and demolition waste reduction. And for the comparison and the baseline, we used a published EPD with a conventional ethics. The findings from this case was, of course, the integration of design for disassembly methodologies into the design phase was very, very important. Replacing the chemical fasteners with mechanical ones allow the selective demolition and drastically reduces the construction and demolition waste. Also, related to materials, with careful material selection, again, we had an improvement. For example, using inorganic coatings on cement boards, it was able to avoid landfilling after the end of life. So, selecting the appropriate inorganic coating for this material, we could have a reduction of construction and demolition waste close to 98.5%. Also, using lightweight cladding, again, with mechanical fixation, it was, let's say, ready to give a construction and demolition waste reduction up to 60%. So, concluding, we can say that the life cycle supply chain holds a significant potential to drive sustainability in construction. For example, by early adoption of design for disassembly principles, by careful material selection, and of course, implementing efficient logistics and screening all the key suppliers, it is possible the technology developers to enter the market with a reduced and improved environmental performance of their products. That's all from me. Thank you.
Any question?
Is there another presentation?
No, it's the last one, and we close. We close on time. We have time for one question. You don't have.
Yes,
please.
Good. Very, very interesting. Thank you. And I'm also reflecting on what we do. And it's true that, well, maybe Giulia didn't mention because it maybe not necessary, but when we looked for EPDs, we also decided quite early on that we will only, for the building level, at least use phases A1 to A3 of EPDs because we couldn't find the other phases.
Yes.
Very
rare.
So that, that's another challenge that we never mentioned. But do you have a French partner on the project or on your project? No. Because as far as we know, so we looked at EPDs from different countries. The French regulation is the most strict one. And very recently, they're like, no, you have to include everything and all the assumptions fully transparent. So actually, there's a lot of pressure from the French government to give you the most accurate EPDs. But no, the other countries, not really. Maybe they will be pushed further on to give you, so that you can have more transparency and carefully select the logistics supply chain, which is very, very important. It makes, I think, a big difference. And for the baseline, you said you had trouble finding a baseline. Yes, it's because it's an innovative technology.
It is an innovative technology.
Yeah,
always you need to take some assumptions, but
yes,
you need to have also some traced data.
Yes, so I think the best you can do is to take generic EPDs for the materials that you use, if they are available, like generic concrete, and you need to justify that you have alternative materials, and if you put them, so.
Yes. Right.
But very interesting, and I'll look into
It's a challenging
Yes, yes.
task.
So
Yeah.
perhaps very quickly, you had 3 presentations today. So we saw specific materials. I mean, we saw the whole, say, overview of the project. What's the next step? Because there could be specific applications, but then there is this, what you showed now is much bigger. So if you very briefly can say, let's say, what's the next ambition?
Even
What is most
I'm not the
familiar?
coordinator, I can, let's say, show you an overview. All these 5 technologies can be, let's say, enter the market by themselves, or can be integrated as a retrofit kit. So at this moment, the project is, let's say, examining the way that they will enter the market or the business model, because some of these are collaborated, let's say, results. So we are, this is the last year of the project. So at this moment, the technology providers and the other partners are trying to find the business model in order to go to the next steps. Most of the technologies are in high TRL, except the printing one, which will reach TRL 7. But all the others are, let's say, ready to do the next step.
And in terms of patenting, is there already?
I don't know.
I can't really answer you. I don't know, because as they have different approach to the market, I don't know if they have been doing this kind of patenting analysis assessment prior to try to do that. So I don't really know. It's up to the technology providers. Okay.
Okay, thank you. I think that we can close the session. I want to thank José Luis, Juan Gabriel, Carlos, Giulia, and Miriam for the presentations. Also all the projects like INPERSO, SNUG, and LEGOFIT, and all of you for coming. And see you next year, probably in Luxembourg for Sustainable Places 2026. Thank you.